sound? Learning objectives. How is sound produced? Types of sound. Propagation of sound and speed of sound. Reflection of sound, echo. Sounds produced by living beings. Sounds produced by musical instruments. Noise pollution. How do we hear? Every day we hear different kinds of sounds. A sound is made when something vibrates. You may hear the wind blowing through the trees, a clock ticking, the ringing of a school bell, birds chirping at trees, the voice of your parents and the crying of a baby. Many sounds make our world beautiful. Most people enjoy singing of birds, listening to music, as sound in the form of music gives pleasure and relaxation. On the other hand, we also hear a lot of sounds that are unpleasant, such as the noise of loudspeakers, the roar of engines, the noise of traffic or the blast of crackers. Without sound we would not be able to communicate with each other, we would not be able to talk to our friends, there would be no music. Just imagine living in this world without sounds. Thus, sound is very important in our lives. In this chapter we will study about sound. We will also study how sound is produced, how it is propagated and how we are able to hear it. Sound around us. How is sound produced? First of all, let us find out how a sound is produced. Sound is produced when something starts vibrating. Vibrating motion means moving forward and backwards, to and fro motion. You can yourself make vibrations and hear the sound produced. Let us perform some activities to feel the vibrations. Activity 13.1. A. Put some small buttons on a table. Now bang the table with your fist carefully. You will see that the buttons jump up and down. Refer to the figure. The buttons jump up and down because the table vibrates when you bang your fist on it. Table vibrates when you bang your fist on it. B. Take a rubber band. Slip the loop of the rubber band over a doorknob and pull it with one hand to make it tight. Now plug the rubber band with your finger. You will notice that it vibrates and you hear a sound. This sound is produced as long as the rubber band is vibrating. Once the rubber band comes to rest, the sound stops. A stretched vibrating rubber band produces sound. C. Take a steel ruler and hold down one end of the ruler on a table, and pluck the other end. You will hear a sound as the ruler vibrates and the sound will stop when the ruler comes to rest in its original position. Sound produced with the vibrating steel ruler. Whistling sound is produced when air vibrates. Pieces of paper jump and sound. D. Take a bottle half filled with water, and blow across the mouth of the bottle as shown in figure. You will hear whistling sounds. Try this activity with different amounts of water in the bottle. You will hear different sounds every time. This is produced by the vibration of air. E. Take a drum or a tabla. Place some small pieces of paper on the surface. Strike the membrane of the instrument with your hands or a stick. You will notice the pieces jumping up and down and hear sound. The pieces of paper show the vibrating motion of the drum membrane, thus producing sound. A tuning fork. Vibrations of prongs. The vibrating prongs cause sound. F. A tuning fork is an instrument used in laboratories for study and research purposes. Hit the prongs of the tuning fork on the table. You will hear a sound as the prongs vibrate. You can further notice the vibrations by bringing a table tennis ball tied and suspended by a string near the vibrating prongs. The vibrations cause the ball to move to and fro. We have seen how sound is produced. Now let us study some characteristics of the vibrations that produce sound. Characteristics of vibrations. Vibratory motion is known as oscillatory motion and vibrations as oscillations. This oscillatory motion has been studied well by many scientists in different ways. This extensive study has led to the definition of some characteristics of vibrations. These characteristics determine the quality of sound produced. You must have noticed that generally women have sharper sound than men. Some instruments produce loud noise and some produce irritating noise. Thus, the quality of sound depends upon three main characteristics. Let us learn more about them. A time period. Take a small ball and tie it with a thread. Now suspend the ball and move it sideways slowly once or twice. You will see that it moves to and fro, resulting in an oscillatory motion. The motion of the suspended ball is referred to as the oscillations of a simple pendulum. Mark the three positions of the ball as A, O and B as shown in the figure. A movement from A to B and then back to A is referred to as one oscillation. Use a stopwatch to find out the time taken by the ball to complete one oscillation. This is called as time period. Thus, time taken by a pendulum to complete one oscillation is called time period of that pendulum. If the length of the string used remains the same, you will find that the time period of this pendulum remains the same even if you take several readings. Oscillations of a simple pendulum. B. Amplitude. Refer to figure and see that the ball moves from A to O, from O to B, from B to O, back, and then finally from O to A. Thus, O is the central position of the ball. The ball passes through this position twice in one oscillation. A and B are two extreme points of this oscillatory motion, and these points determine a quantity called amplitude. Amplitude is the maximum distance which the ball covers from its central position. In the given figure, OB or OA is the measure of amplitude of the oscillation. This measure is not constant for a pendulum. The amplitude of an oscillation depends upon the force applied to start the oscillatory motion. C. Break a rubber band and tie its both ends to some objects. Now pluck the band with your finger. This results in an oscillatory motion as shown in figure. D. Frequency. With the help of a stopwatch, measure the time taken by the pendulum to complete 10 oscillations. Then divide the number of oscillations by the time taken. The resulting figure will be the number of oscillations completed in 1 second. This measure is called frequency of oscillation. The unit of frequency is Hertz. Hertz, named after Rudolf Hertz, who was a German scientist. If we say that a pendulum has a frequency of 20 Hz, we mean that it completes 20 oscillations in 1 second. Frequency and amplitude are the two factors that determine the pitch and loudness of a sound respectively. The shrillness of the pitch of a sound is determined by the frequency of vibration. More the frequency, or vibrations per second, more is the pitch, and less the frequency, less is the pitch. You can easily notice the difference in pitch in various sounds. Women have a higher pitch voice than men. Flute also produces a high-pitched sound. Instruments such as tabla, drum have a low-pitched sound. Similarly, the loudness of the sound is determined by the amplitude of vibration. Some sounds are low, some sounds are high. We know that sounds are produced when something vibrates. Sound produced is loud or high when the distance between the extreme position and the center position of the vibration is more. Take a rubber band and stretch it between 2 points A and B. Now plug the band in between and notice the sound produced. When it comes to rest, plug the band harder to point C by applying more force. In this way you are increasing the amplitude of vibration. You will notice that this time, a louder sound is produced. Low and high-pitched sounds. Types of sound. We cannot hear all the sounds produced in this world. If a sound is too low or too high, we may not hear it at all. This is because our ears have limitations. Human ear cannot hear frequencies less than 20 vibrations per second and frequencies more than 20,000 vibrations per second. This range of frequencies between 20 Hz to 20,000 Hz is called audible range. The vibrations having a frequency below 20 Hz are called infrasonic, and those having frequency above 20 kHz, 20,000 Hz, are called ultrasonic. We cannot hear the sounds of these vibrations, but animals can. Animals like dogs, monkeys and leopards can hear the ultrasonic frequencies. Nowadays, special high-frequency whistles are available. When you blow air in them, an ultrasonic sound is produced. You will not be able to hear the sound, but the dogs can. These whistles are used to train dogs. You must have seen bats flying very fast during night time. You will be surprised to know that bats cannot see. Bats find their way by emitting special ultrasonic sounds. These sounds help them in finding their way and keeping them away from hitting obstacles. How this is done, we will study later. Ultrasonics have been put to several uses by human beings. The uses vary from medical science to housekeeping to industries. Ultrasound scanning is done by radiologists to diagnose several diseases. This scanning makes use of ultrasonic sound waves. The development of a fetus inside the mother's womb is checked using this scanning technique. Ultrasound vibrations are also used in advanced dishwashers. The ultrasound is used by ships in seas to find the depth of seabeds. In metal industries, ultrasound is used to detect flaws in the metallic structure and the thickness of metals. Propagation of sound and speed of sound. We have learnt how sound is produced, what its various characteristics are, what makes it loud or shrill. Let us now study the propagation of sound. We are able to hear a ringing bell even from a distance. Our dog is able to hear our voice from a long distance. This is possible because sound can be propagated, however it requires a medium to travel from one place to another. Sound can travel through air, liquids and solids. Sound travels in the form of sound waves. Throw a stone into a pond. Ripples are formed where the stone hits water. These ripples are similar to the vibrations produced by an object. When something vibrates, it moves the air around it. If you ring a bell, the bell vibrates and makes the air around it vibrate, though we are not able to see these vibrations in the air. These waves are called as sound waves. Sound waves are formed in solids, liquids as well as gases. Sound traveling through a thread. Let us perform some activities to see how sound travels through solids, liquids and gases. Activity 13.2. A. Put your head near a table in such a way that one ear rests against the table. Now close the other ear with your hand as shown in figure. Ask one of your friends to tap the table on the other side. You will hear the tapping sound. This sound has traveled through the table, solid, to your ears. This proves that sound can travel through solids. B. Place a watch on a bench. Stand away from the bench so that you cannot hear the ticking of the watch. Then place one end of a long wooden rod on the watch and the other end to your ear. Now you will be able to hear the ticking of the watch. C. You can also make a toy telephone at home. It is a toy and also an apparatus that helps in proving that sound can travel through solids. Take 2 tin cups or ice cream cups. Cut small holes in their bases. Take a long thread and with the help of a pin, attach the thread at the base of each tin. Your toy telephone is ready to use. Place one cup against your ear and ask your friend to speak something into the other cup at a distance so that the thread remains taut. You will be able to hear your friend's voice. D. Take an electric bell and place it inside a special jar attached to a vacuum pump. Connect the bell with the battery placed outside the jar. Seal one end of the jar. Ring the bell. You will be able to hear it perfectly well. Now start the vacuum pump to extract the air from the jar. In this way a vacuum-like condition is created in the jar. Now again ring the bell. This time you will not be able to hear the sound of the bell. This is because all the air has been removed and there is no medium for the sound to travel. There is no need to perform activities to prove that sound can travel through air, as it is a common experience in our daily life. We are able to speak to a person, hear another person only because sound can travel through air. Sound travels easier, quicker and farther through solids than through air. A distant train can be heard more easily when one puts one's ears on the railway track, as metal lines are good conductors of sound. Ripple made by throwing a stone in the pond. Ringing of bell, vibrations around it. Sound can travel through solids. Sound traveling through a wooden rod. Electric bell experiment. The following activity shows that sound can also travel through liquids. Take a balloon and fill it with water. Now hold the balloon close to your ear. Scratch the farther side of balloon. You will be able to hear the scratching sound. This is possible because sound propagates through water and reaches your ear. You can also perform this activity with a ticking clock on the farther side. Sound can travel in water. Sound is produced when stones are stuck in water. Take 2 stones and hold one in each hand. Now dip your hands in a bucket with these stones. Strike them together inside water. You will be able to hear the sound produced. This is possible because sound can travel through water. Now that we have performed several activities to see that sound is able to travel through solids, liquids and air, let us learn about the speed of sound and how it varies in solids, liquids and air. During the rainy season, we sometimes hear the thundering sound of clouds and see lightning in the sky. Try to observe this lightning carefully. You will find that we are able to see lightning flash first and then the thundering sound is heard. This is because light travels faster than sound. The speed of light is 3 × 10 into 8 meters per second and the speed of sound is just 340 meters per second in air. This means that if a person fires a pistol in the air at a distance of 680 meters from you, you will be able to hear the shooting sound after 2 seconds. Nowadays, technology has advanced so much that very high-speed aircrafts are being designed. Some of these aircrafts are able to exceed the speed of sound called the sound barrier. Aircrafts that can fly faster than the speed of sound are called supersonic. You will be surprised to know that Concorde aircrafts travels at around twice the speed of sound. Throw a ball on a wall. It will bounce back after hitting the wall. Similarly, sound waves bounce back after hitting an object. We will study about this bouncing back of sound in the next section. Reflection of sound, echo. If you throw a stone into a pool, waves spread outwards. Sound waves also spread like this. If the sound waves hit a solid object, they reflect. This reflected sound is called an echo. The reflection of sound is similar to the reflection of light. However, shiny or smooth surfaces are not required for sound reflection. The extent of reflection of sound is different in the case of different materials. Heavy curtains, cork, thermocol are bad reflectors of sound. These materials absorb the sound waves. On the other hand, plywood, metals etc. are good sound reflectors. The sound-absorbing materials are used in cinema halls, auditoriums, recording studios to stop the echo. In these places, echoing can affect the recording or hearing of original sound. Thus, sound-absorbing materials prevent this sound disruption and ensure that sound comes from the source only. Let us perform an activity to demonstrate the reflection of sound. Inside a recording studio. Activity 13.3. Take 2 big sheets of cardboard and roll them to form 2 tubes. Take a plywood sheet and arrange these 3 as shown in figure. The plywood sheet should be arranged in such a way that small sounds cannot cross them. Now place a timepiece at one end of a cardboard tube. Place your ear at the second tube and adjust the position until you hear the ticking sound. Now mark this position of tubes. You will notice that only in this position, a clear sound is heard through the tubes. If you measure the angles between the tubes and the central position, you will see that the 2 angles are equal, similar to the law of reflection of light in which the angle of incidence is equal to the angle of reflection. Reflection of sound. Sound reflecting from a wall. Human beings have a special sense organ for sound detection, and that is the ear. Human ears are capable of hearing the original sound as well the reflected sound or echo. But they have a limitation. Our ears can hear 2 sounds distinctly only if there is an interval of 1/10 of a second between the 2 sounds. This means that 2 sounds must reach our ears with a minimum interval of 1/10 1/10 of a second, otherwise we will not be able to hear them separately and distinctly. This fact has a practical application also. Suppose we are standing at a distance of 15 meters from a sound reflecting surface and we produce a sound. Can we hear an echo? The answer will be no, as explained below. We know the speed of sound in air is 340 meters per second. The total distance covered by sound in coming back to us after reflection is 30 meters. This is so because sound has to travel an equal distance forwards and then backwards after hitting the reflecting surface. We know distance equals speed multiplied time. Time equals distance, speed. Thus, the echo of the sound produced takes 0.08 seconds to reach us. There must be an interval of 1/10 seconds, 1 second, or more between two sounds to be heard distinctly. As this was not so in the above example, we were not able to distinguish between the original sound and the echo. Can you find the minimum distance to be able to hear an echo separately? Since the speed of sound in air is 340 meters per second, the distance traveled by sound in 1/10 of a second is d equals s multiply t equals 340 meters per second multiply 1/10 s equals 34 meters. Therefore, we are able to hear an echo if we are at a distance of a minimum 17 meters from the reflecting surface. Bats fly around when it is dark, but never bump into anything. When a bat is flying, it makes high-pitched squeaking sounds. These sounds are of a very high frequency and these bounce back from objects and back to the bat's large ears. Figure. This echo gives them the exact location of obstacles in their way. Echolocation by bats. A bat can even catch small insects by the echoes which bounce back to them when the bat squeaks. Sci fact. For years people wondered how bats could fly at night without crashing into things. Did they have some special kind of night vision to help them? In the 1930s, scientists discovered that bats have a kind of natural sonar that allows them to see with their ears. Using only sound, bats can follow and catch prey in total darkness. This amazing sonar system is called echolocation. Dolphins live in the sea where the water is muddy and dark. They are also able to find their way and find their food by making sounds. As a dolphin swims, it makes very high squeaking sounds. These sounds are bounced back by the rocks and fishes in the water. Ships use echoes to learn about things underwater. A sound signal is sent down from the ship into the sea or ocean. The sound bounces back from the seabed. Knowing the speed of sound in sea water, we can determine the depth of ocean by noting the time taken by the sound to come back. The longer the sound takes to come back to the ship, the deeper the water is. The sound signal also bounces back from a large shoal of fish. This helps the fishing trawlers in locating the fish so that they can put their nets there. Sound helps in locating fish. Sounds produced by living beings. Animals. Animals make sounds in many different ways. Birds are able to produce sound by means of a ring of cartilage, called syrinx. Syrinx is present in their windpipe. Frogs and toads use their voices a lot during the breeding season. A bullfrog produces croaking sounds, and to increase the loudness of its croaks it inflates its throat like a balloon. A bee makes a humming sound as it flies. This humming sound comes from the fast vibrations of its wings. Some insects make sounds by rubbing one leg against a wing. Grasshoppers make sounds in this way. Thus, every living organism has some way to produce sound for communication, for security, or for procuring food. Bullfrog and its distended throat. Grasshopper rubbing one leg against a wing to make sound. Bee making humming sound. Human beings. Humans can make many sounds. We may make sounds with our hands and feet. However, most of the sound we make is with our voice. Our voice comes from our throat. Gently place a hand on your throat and slowly sing a song or just make a humming noise. You will be able to feel vibrations in your throat. Inside our throat we have a voice box or larynx with which we are able to produce sounds. Inside the voice box are two folds of ligaments known as vocal cords. These vocal cords are arranged in such a manner that they have a narrow slit between them for air passage. When we try to speak, air from our lungs forces itself out through this slit. As a result, the vocal cords vibrate and a sound is produced. We can change the way our vocal cords vibrate. When the vibrations are fast, vocal cords are tight and we produce sound of a high frequency. When the vibrations are slow, vocal cords are loose and we produce sound of a low frequency. We alter the position of our mouth and tongue to utter different words. The difference in the pitch of voices produced by children and ladies is a result of the size variation of vocal cords. Women have shorter vocal cords than men and children have very short vocal cords. As they grow, the size of vocal cords also increases and their voice thickens. Sound produced by human beings. Sounds produced by musical instruments. There are several types of musical instruments. These instruments are used to produce sounds of varying quality. Some instruments produce high-pitched sound, some produce low-pitched sound, some produce loud sounds and some slow sounds. Basically, all musical instruments produce sounds that seem pleasant to human ears. There are three main categories of musical instruments. These are A. Wind instruments, B. String instruments, C. Membrane or percussion instruments. A. Wind instruments are those instruments which make use of vibrations of air column to produce sounds. Some wind instruments are shown in figure. These are flute, shehnai and nadaswaram. These instruments produce sounds when air is blown into them. These have holes in them, which are opened or closed with fingers to vary the length of air column, thus producing different sounds. Wind instruments. B. String instruments are those instruments which make use of vibrating strings to produce sounds. Some of the string instruments are shown in figure. These are violin, guitar, veena, sitar. These instruments have a varying number of metallic strings in them. These strings are plucked to produce sounds. The sequence in which these strings are plucked produces a musical sound. The pitch of sound is altered by varying the length of the vibrating strings. Stringed instruments. C. Membrane or percussion instruments are those instruments which have a taut membrane or skin over them. Some of these are tabla, mridangam, drum, dholak etc. shown in figure. When the stretched membrane of these instruments is hit with hand or sticks, the vibrations of the membrane produces sounds. The harder we hit on these membranes, louder is the resulting sound. Also, the pitch or shrillness of these sounds can be increased by stretching the membrane. There is another category of instruments which produce musical sounds when simply struck. These are the jaltarang, manjira, ghatam etc. In jaltarang, many small bowls filled with varying amounts of water are struck gently with two sticks. This results in musical sounds. In manjira, there are metallic plates which when struck produce musical sounds. Thus, sounds which are pleasant to hear are called musical sounds. These are produced by regular vibrations. There are several sounds which cause irritation upon hearing. These sounds are referred to as noise. Try one activity to see for yourself the difference between noise and music. Take a metal box and fill it with coins. Now shake the box vigorously. You will hear a sound which will be irritating. This is noise. If you gently strike the coins with a metal stick, the sound produced will be musical, if coins are struck in the right order. Percussion instruments. Noise pollution. Noise is unpleasant or unwanted sound produced by regular vibrations. Noise from motor vehicles, aeroplanes, machines and sometimes loud sound from radios and televisions can annoy us and is referred to as noise pollution. Noise can disturb our sleep and make us ill. Very loud noise can damage our ears. Constant loud noise causes gradual hearing loss. It also leads to high blood pressure, nervous tension and lack of sleep. A person may suffer from lack of concentration and may become prone to heart diseases. People who work in noisy places sometimes have to wear earmuffs to protect their ears. In various large towns and cities, jet aeroplanes are not allowed to take off during the night. Cars, motorcycles and lorries are fitted with silencers to make their engines quieter. People design buildings in such a way so as to minimize the noise. Windows that are double-glazed keep out some noise come inside in minimum intensity. To deaden the noise between rooms and offices, the hollows between the walls are sometimes filled with foam or other soft materials. Soft materials help to keep out noise by absorbing vibrations. We all need a quiet place to stay and remain healthy. How do we hear? Ears are the sensory organs that help us in hearing sounds. Without our ears, we would not be able to hear the sounds around us. The part of the ear we can see is called the outer ear and consists of pinna and ear canal. It picks up the sound waves from the outer surroundings and leads them to an ear canal. Ear canal is responsible for passing the air vibrations to reach the tightly stretched membrane called eardrum from where the middle ear starts. Other constituents of the middle ear are three bones which transmit the vibrations to inner ear. These three tiny bones carry vibrations to a tube which looks like a snail shell. Inside this tube are many small nerves. These nerves transmit the vibrations as nerve impulses to the brain, and the brain processes these impulses to determine what we have heard. A diagram of our complete internal ear is given above. Structure of ear, internal. Keywords. Amplitude. Maximum displacement of an oscillating object. Vibration. To and fro motion of an object about some fixed equilibrium position. Frequency. Number of oscillations per second. It is measured in hertz. Hertz. Unit of frequency. Tuning fork. Instrument producing sound of a single frequency. Echo. Sound heard after reflection from a high wall or obstacle. Summary. A vibrating object produces sound. Time taken by a vibrating object to complete one oscillation is called its time period. Amplitude of vibration is the maximum distance to which a vibrating body moves from its mean position. Number of oscillations completed in 1 second is termed as frequency of oscillation. Frequency is measured in hertz. The audible range of frequency for human ears is 20 to 20,000 Hz. Frequencies beyond 20,000 Hz are termed as ultrasonic frequencies. Sound needs a material medium for propagation and it cannot travel through vacuum. Speed of sound is maximum in solids. Reflection of sound causes echo. Musical instruments produce musical sounds due to vibrations of air or string or membrane. Unwanted sounds are termed noise. Too much noise or loud noise causes noise pollution.